time. Look at the distance. Look at the time. You can catch your answer well. Good, my dear. What about the other example? Look, my dear. Two cars. The first move 100 meters in 1 second, while the second moves 100 meters in 3 seconds. By the same, which of the two cars is the faster and why? Get your given. 100 meters for 1 second. Another 100 meters for 3 seconds. What is the constant here? The constant here is distance. Catch the answer. Which one the faster? Fly, fly, and catch it. The first car, yes, is faster than the second car. Also, sure, ask yourself why. This is back because the first car takes a shorter time than the second car. But at constant distance and the speed we know inversely proportional with the time. Directly with this distance, inversely with the time. Catch it, my lovely students. What about to fly to this? What types of the speed? We know the speed, it has different types. We know that. Let's catch the first, uniform speed. Non-uniform speed. What about the third? Yes, relative speed. So, the types, uniform, non-uniform, relative. Let's see how can we know the difference between all of them. The two runners move beside each other. This it means uniform speed. Suddenly, one of them moves fast and fast and fast. So, it's changing its what? It changes speed. So, the first, regular speed. Regular, my students, it means uniform. So, what about the distance? What about the time? Body moves equal distance in equal period of time. Both are equal. So, we say uniform. Uniform speed, it has an example. This example, my crazy car back again. Did the car start to move? It's moved about 3 meters in 1 second. After a while, the crazy car move again, and the distance becomes, 3 meters in another 1 second. The distance is a constant, and the time is a constant. It's okay, why not? What about if it moves again? When it moves again, the distance stays 3, and the time stays 1. Do you think why all of this? Distance equal, time equal. Catch it, my dear. It's a uniform speed. Why? In this example, body gets equal distance in equal time. Great. This it means uniform. Let's see this. Non-uniform speed or irregular speed. Irregular or non-uniform, I know you know it well. Tell me, different what? Different what? Look at this. Body moves an equal distance in equal period of time. Time is changed. Distance is changed. How can I know? Look at this example. My crazy car starts and move again, but now it moves 4 meters in 1 second. After a while, it moves again, and look at this. The distance is changed. What about the time? The time is not changed. It stays constant. Now, move again, my dear. Sure. When it moves again, you can find, yes, distance is changed, but the time is not. All distance is changed, but the time is a constant. What this mean? This means non-uniform. Look, in this example, the car with non-uniform speed, because it moves in equal distance in equal period of time. Equal in unequal, this it means non-uniform. Wonderful and easy. But we have another important example. Look at this example. The car moves the distance here for 1. It moves again. The distance becomes 4, but the time is changed to 5. It moves again. What this mean? It means the 4 meter 3 seconds. The distance is not a change. What this mean, my dear? The time is a constant. The time is not constant, and the speed is a constant. Look at this. This car, it moves, yes, with non-uniform speed, equal distance and equal of time. So the uniform, it has two factors. For the first, equal distance and equal time, or the opposite, unequal distance for equal time. It's great and easy. Let's fly for the last one. Note. What's your note for this? Look, regular speed is considered average speed. Regular, irregular, average. This means average speed. It means what? Go and back, go and back. It means total distance moved by the body dividing by the total time. Where is the law? The law is here. Average speed equal total distance, total time. Wonderful. But take care. V is not V. Say V dash. Why we say V dash? To be average speed. Total distance, total time. What about the other one? If the average speed equal uniform, do you think what happened? Speed. This means the motion of the body is uniform motion. Another one, it has a unit. Yes, we know. The unit of the speed, meter per second or kilometer per hour. Both are right. Important to know meter per second for the small one, kilometer per hour for the biggest one. Take care, and this note is very important. My dear, let's see the important example. Take care. This example is very important because it has a lot of answers. Look at this. At the first, a runner covers a distance of 80 meters in a starting track in 40 seconds. Then he returns back and walking in 20 seconds. My dear, take care. When he starts, he moves 80 meters in starting track. Then he gets a time about what? 40. When he back again, it gets another 20 seconds. What do you want from this question? You can say, number one, find the racer's average speed. Number two, the average speed while returning. Number three, the racer's average speed during all trip. To catch this problem, get it as step by step. For the first one, the racer's average speed. When I ask me where is the answer, yes, it's my answer for the first, the racer's average speed. When it go, this is means what? He goes by about, yes, 80. Look at this, right below. Average speed, total distance, total time. 80 over 40 equal 2 meters per second. My dear, don't forget, V dash, it means average speed. 80, it means distance. 40, it means the time in second. Don't forget important thing. This is in one direction. Just he move forward. What about when he returning? This is, we'll see it now. V dash again. The racer's average speed while returning. He go 80. So directly when we say returning, also he returned by 80. The total distance over total time, this it means average speed. It means 80 over 20 equal 4. Do you think what this means? This it means total distance, total time for 4 meters per second. During return only. If you want to catch all trip, what you do for this? You can say the racer's average speed during all trip. When I say this word, don't forget to say I go 80 and return 80. So How many distance? I have the distance. I go by time and return in another time, and 2 time. The same law. Total distance over total time equal 80 plus 80. Go and back. 40 plus 20 for the time for forward and backward again. It will be 2.6. 2.6 what? Meter per second. Because we know the average speed, it has an important unit. What is the unit of all speed? Meter per second or kilometer per hour. But in this case, we work about the small unit, meter per second. It's great, my dear students, to hear that. Going 80, back 80, time 40, back 20, the total 2.6 meter per second. Look, relative speed. Relative speed, it means what? When you move and the car moves beside you suddenly, or the bus moves suddenly, do you think, what happened? Your speed, in this time, it means relative speed. So, the speed of the moving object relative to the observed